Hi, welcome back to the Algebra 2 series. Today we're looking at example 6, which is probably the most difficult of our ellipse graphs, and that's because our equation is not in the standard form. Instead, we're going to have to complete the square in order to get the x terms written in the way that we like to see them, and the y terms written in the way that we like to see them. And typically that's going to look something like this when we're finished: x minus h squared, and then plus y minus k squared. Now we're not certain exactly which one is in the denominator, a or b squared. We're not sure, but just for the sake of this example, I'm just going to write an a squared here and a b squared here. But as we can see, these numbers may reverse if one or the other is changed in size. So the larger of the two will become our a squared. But we'll get to that eventually. Let's go ahead and start with the completing of the square. Now we've done these problems before, but this one looks like it's quite a monster. In the first case, we're going to factor out the 16 from the x squared and the x term. So we end up with x squared minus 2x. I'll put my blank here so that I can complete the square. The second part, 9, y squared minus 8y, that coming out of the 72. Again, another bracket. And then negative 16 with two blanks here. These are to make up for the values that we add inside those parentheses. In completing the square, I always like to go down to the next step first and kind of fill in these values. This will be, in the first case, an x. And again, we complete the square with a subtraction of 1/2 of that middle term. Square it, we get plus 1. Notice that in this case we need to multiply it by the 16. That adds a 16 on the other side. In the second part, the y squared minus 8y produces a y minus 4. Sorry, that quantity is squared. And then square it, we get 16. Again, we multiply by the 9. I'm going to do that in my head. That's 144, and then I'll add that over here. Notice that we had a subtraction of 16, or a negative 16, plus 16 and 144, which makes 144. This problem is kind of interesting because for a couple of reasons. One of them is this 9 and 16, which we know multiplies to 144. But over on the right-hand side of the equation, we're trying to generate a 1. So we'll divide both sides by 144, giving us 16, quantity x minus 1 squared over 144. And then the 9 multiplied by the y minus 4 squared is also over 144. And notice that those quantities will cancel, leaving our final values, x minus 1 quantity squared. This is over 9 plus y minus 4 quantity squared, and this time it is over 16. So I was incorrect in my original assessment. This is going to end up being the b squared value, being the smaller one. So let's move on down here a bit. I did not leave a good enough space to graph that, so let's move this on down here somewhere. That looks pretty good. Now we have a center coming from our values of h and k. The center is going to be 1, 4. And of course I begin this way making a little info box, and that is going to have all of the values that we're looking for in our ellipse. The center, we're going to want to have the vertices, the foci, and the endpoints of the minor axis, EMA. Let's begin with our center here. This is going to be a rather large. So we are at the value 1, 4 for our center. There's our center. Now, because the 16 is underneath the y term, that means that the compensation we need to do for the y term is the square root of 16, or 4. So this is equal to a squared. So if we just write these out on the top, I'll put them up over here. A squared is 16, so a is 4. B squared is 9, and so b is 3. Now these are representing the distances from, for example, for the a, the distance from the center to the vertex, and we'll be going up and down. That would put one vertex here on the axis and the other one 4 units up. So up here somewhere. That'll be a vertex and that'll be a vertex. And the b value, this one here, is representing the distance from the center to the end point of the minor axis. So I will go across 1, 2, 3 this way, and I'll put an EMA over there, and 1, 2, 3 this way, and I'll put an EMA right there. And then I'll carefully graph this from, I like to graph from the vertices. I don't know if it makes all that much difference. There's our picture. The only thing we need to put in is our foci, and the foci are computed by writing our Pythagorean identity. A squared is equal to b squared plus c squared, as we see from the ellipse. It's going to produce 16 is equal to 9 plus c squared. In this case, c squared is 7, or c is the square root of 7, which is somewhere between 2 and 3. I'll just move it down here about 2.5 or so. I'll put a focus in there. I'll go up about 2.5, put a focus right there. So I have my picture drawn, and all I need to do then is figure out those in the info box. My vertices are up and down 4 units, so therefore I'll have 1, comma, 4, up and down 4 units. The foci are also up and down. That's why I put them right underneath the vertices. They look pretty much the same. That's up and down. And this time it's radical 7. Don't approximate that. Just put in the correct value, radical 7. And the EMA, or the endpoints of the minor axis, are left and right. So I'd write 1, left and right, 3 units, comma, and it is up 4. That's to find those. And there you have everything that you need inside of your info box that gives information about this ellipse. Of course, the real hard part about the computation is getting it into this proper form here, this standard form, so we can see all those things. Well, there you go.